haven't done so already, go ahead and pause this video just so that you can try out these warm-up problems. Okay, so x equals 1/2, nice and easy equation. When you have a fraction divided by a fraction, you just change it to multiplication and multiply by the reciprocal of the denominator. So root 3 over 2 times 1 divided by 1/2 would be root 3 over 2 times 2. And that simplifies to be root 3. And then when we do this, it simplifies to be root 3 over 3. Now you may have done this before. Looks kind of familiar from the unit circle. So let's just fill in our tangent values. Recall tangent theta is equal to y over x. So the y value over the x value. So tangent of pi over 6 would be 1/2 over root 3 over 2. But we actually already know what that is from our warm-up. That is equal to root 3 over 3. So you're going to fill that in. Okay, what is root 2 over 2 divided by root 2 over 2? That is simply 1. So tangent of pi fourths is 1. Wow, jumping all over the place. Okay, root 3 over 2 divided by 1/2, that is from part B of the warm-up, root 3. As you continue on, the values will be the same, just the signs will be different. Negative root 3 over 3, and continue. Then, of course, when I have 0 divided by 1, that's 0. 1 divided by 0 is undefined. 0 divided by -1 is 0, and tangent of 3 pi halves would also be an undefined value. This is just going to help us just do less work later. Okay, solve for all angles on the interval between 0 and 2 pi, not including 2 pi. So you see how there's no line under here? So if the answer is 0 / 2 pi, since those are the same angle, then you would write 0 as your answer and not 2 pi, because 2 pi is not included on the interval. So before we were doing things like, hey, what is sine of pi fourths? And you would go to your unit circle and see that the y value at pi fourths is root 2 over 2, and you got your answer. Okay, now we're going to be given sine of some angle is the value root 2 over 2, and now we're going to solve for the angle. Okay, x represents an angle right here. So first of all, you're going to add 1 to both sides. We get 2 sine x equals 1. Divide by 2. Sine x equals 1/2. So we're trying to find where is sine equal to 1/2. Remember the following. Cosine corresponds to x, sine corresponds to y, and tangent is y over x. Okay, so when they're asking for sine of what angle, the angle x is what they're calling it, sine of what angle is equal to 1/2, they're asking for the y value of what angle or angles is equal to 1/2. So I'm going to look for the y value being 1/2. Oh, I see that right here. It's equal to 1/2. So pi 6 is one of those angles. Where else is the y value equal to positive 1/2? That's also at 5 pi 6. Are there any more angles? Not between 0 and 2 pi. Based on the interval they gave us, we have 2 angles that satisfy the equation, pi 6 and 5 pi 6. We did not use 7 pi 6 because sine was negative 1/2 and they were asking for sine being positive 1/2. Okay, remember to treat your trig function as if it's your variable, it's your unknown, you're trying to get it by itself. So we're going to subtract 2 on both sides. 3/2 minus 2 is 4/2. So 3/2 minus 4/2 equals cosine theta. That would be cosine theta equals negative 1/2. So when is cosine equal to negative 1/2? When is the x value equal to negative 1/2? Not in the first quadrant because nothing's negative there. Where is cosine negative? Well, cosine is positive in the first and fourth quadrants. So our answers for this one, our answer for this one will come from the second and third quadrant, where cosine is negative, and that would be 2 pi thirds and 4 pi thirds. Negative 1/2 and negative 1/2. Okay, let's continue. So, you have something is being multiplied by sign, -8. So we need to divide both sides by -8. -4 over -8 is just positive 1/2. 1/2 times √3 is √3 over 2. So where is the y value? √3 over 2. Positive. Sign is positive in the first and the second quadrant. So that's where your two angles will come from. √3 over 2. So that would be pi thirds and 2 pi thirds. Right here you can see your y value is √3 over 2 here, and your y value is √3 over 2 here. All right. Trying to get secant theta by itself. Add 5 on both sides. So that would be 1 is equal to secant theta. But what does secant correspond to? We have cosine, sine, tangent. Well, secant is the same as 1 over cosine theta. And I'm going to write the left side as a fraction. Okay? If you have a fraction equals fraction, the reciprocal is also equal to the reciprocal. So I could say that 1 over 1, we're going to flip this side, and that would give me 1. And we're going to flip this side, and that gives me cosine theta equals 1. This is easier than having to do the reciprocal stuff. So I always try to put it into sine, cosine, or tangent. Cosine theta equals 1. Where is the x value equal to 1? At what angle is the x value equal to 1? That is at 0, or 2 pi, or 360, or whatever you're calling it. Well, they said 2 pi is not in the interval. So if you get the angle 0 or 2 pi, you're going to label it only as 0. Let's do some more practice. Okay, now we're getting cotangent by itself. Divide by 4 on both sides. Cotangent theta equals 1. We're going to do the little flipperoo that we did on our last problem. So that would be cotangent is 1 over tangent theta equals 1. We're not flipping yet. And then we flip. So we get tangent theta equals 1. Where is tangent equal to 1? And this is where it's nice that we wrote in our additional values. Okay, so tangent is actually not in the point. It's written to the side of the point, which we wrote earlier on ours. And you have this unit circle on your back page, I believe, of your packet as well. Where is the tangent? Where is tangent equal to 1? Here. And again, tangent would also be equal to 1 here. So theta could equal pi fourths, or it can equal 5 pi fourths. Okay, what if we have a trig function being squared? We're going to divide both sides by 3. Again, just trying to get tangent x by itself. Right now it's tangent squared x. So tangent squared x, x is an angle. Okay, you can use x to represent an angle. We get tangent squared x equals 1/3. How do we get tangent x? Just tangent x. Well, we square root both sides. And we get tangent x equals to plus or minus. I'm going to separate these so that I can get this root out of the denominator. Cool, these pop-ups are fun. Still learning how to use this tablet effectively. that is simply equal to plus or minus 1 over root 3, which we have simplified many times in the past. That's root 3 over 3. So you're looking for where is tangent equal to root 3 over 3 or negative root 3 over 3. Okay, so we might actually get more than 2 answers this time. So where is tangent equal to positive root 3 over 3? At pi sixth and at 7 pi sixth. And where is it equal to negative root 3 over 3? At 5 pi sixth and 11 pi sixth. So all 4 of those are answers. Okay, and the last thing I want to show you is how to write an expression to solve for all possible angles, not just angles that are between 0 and 2 pi. Solve for all possible angles, meaning we're going to write an expression that represents all of them. First, let's get sine theta by itself. So we're going to subtract 5 on both sides. This is a weird looking equation, don't let it scare you. This could be written as 2 separate fractions. So I'm going to write it as 10 over 2 minus root 2 over 2. We're also subtracting 5 on this side, so I'm going to subtract 10 over 2 because that is equivalent to 5. Now, we can see that sine theta is just equal to negative root 2 over 2. They just put all these other numbers in order to make you do more work, okay? You're gonna get values that are on the unit circle, and if you don't, then you don't have to answer the question. You just say undefined. Okay, so where on the unit circle is sine equal to negative root 2 over 2? Negative root 2 over 2. So I go to where the y value is equal to negative root 2 over 2. Sine is positive in the first and second quadrants, so it's going to be negative in the third and the fourth. And where's the y value? Negative root 2 over 2 at 5 pi fourths and 7 pi fourths. So let's take a look. That would be here at 5 pi fourths and at 7 pi fourths. So theta is equal to 5 pi fourths and 7 pi fourths. But let's just say that I took 5 pi fourths and I added 2 pi. Would I get another answer? Well, I would be at 5 pi fourths. I would add 2 pi, and I'd be at the exact same terminal side, meaning I'd be at a coterminal angle. So yeah, I would get another answer. What if you subtracted 2 pi from 5 pi fourths? Would we get another answer? Yeah, because when you subtract 2 pi or when you add 2 pi, you get a coterminal angle. And if 5 pi fourths is a solution for sine theta, then every single angle coterminal to 5 pi fourths will also be a solution for theta. Okay. So I can take 5 pi fourths and I can add any amount of 2 pi or subtract any amount of 2 pi and I'll still get a solution to the equation. Any amount. So I'm just going to use the letter n to represent any integer, right? We can't take half amounts of pi. It has to be 2 pi times 1, 2 pi times 3, 2 pi times 5. Any integer times 2 pi will also get me a coterminal angle, which will also get me a solution to the equation. So 5 pi fourths plus 2 pi times any integer will give me a solution, including 7 pi fourths plus 2 pi n, any amounts of 2 pi, that will also get me another solution to the equation. So you can write your solution. Theta is equal to these two expressions, and that covers all possible angles ever. Because if you can keep going around this circle infinitely many times, you're going to have infinitely many solutions to these equations. That's why they have to restrict it upon an interval. Okay, get tangent theta by itself. I'm going to write this as negative 9 over 3 plus root 3 over 3. And then 3 can be written as 9 over 3. So tangent theta is simply equal to root 3 over 3. Again, they're just trying to get you scared when you look at the equation for the first time. Okay, tangent theta is equal to root 3 over 3. Where does that occur? That occurs at pi over 6. And it occurs at 5 pi over 6. Okay, so for sine, we always had a repeated solution after 2 pi was added or subtracted. For cosine, you will always have another solution after 2 pi. Any amounts of 2 pi are added or subtracted. That's because the period of sine and cosine is 2 pi. But for tangent, your answers will always be opposite from each other on the pole. This would be the pole that I'm talking about, and that is 7 pi over 6. Okay, so your answers are always pi away from each other. Pi away from each other. And it doesn't matter how many times I add pi to pi over 6. If I add pi, I get 7 pi over 6. If I add pi again, I get 13 pi over 6. Or if you subtract, whatever, anytime you add any amount of pi, you will get another solution. So for tangent, instead of writing it theta equals and having to write two separate expressions, because you have some arbitrary amount between your solutions, tangent will always give you solutions that are pi distance away from each other. So you can always write, and we usually start with the smaller one. It just kind of makes more sense to me. Okay, so we can write pi over 6 plus pi over pi n. N, any integer amounts of pi. Now, if I plug in 1, if I take pi 6 and I add 1 pi, what will I get? 7 pi 6. So do I need to write that as part of another expression? No, I don't, because 7 pi 6 is already embedded into this answer. So you don't need to write it as two expressions when you have tangent. The solutions are always pi away from each other because tangent has a period of pi. The solutions for sine and cosine, always 2 pi away from, or well, they're not 2 pi away from each other. You always add amounts of 2 pi because the period is 2 pi and they're not consistently the same distance from each other. And something that our dear old friend Mr. Kennedy, who used to teach at Kennedy, used to call it, and I thought it was kind of fun. Instead of saying 2 pi n, he would always say 2 pin. So you're going to take whatever angles you get between 0 and 2 pi, and then to write an expression for all solutions, you just add 2 pin. If you have tangent, you take the smaller angle and you add pin, and you'll cover all the solutions.